All right, here is my fourth video from section 4 of the Redesign Practice Test 2 in the calculator section. In this section, I'm going to do problems 26 through 30. So in prior videos, I did 1 through 10, and then I did 11 through 20. And then towards the end here, they get a little bit harder, so I go a little bit slower. So I did 21 through 25 in the last video. So I'll pick up here on 26. 26 says, here's a function right here. Which of the following are equal to 1? Well, f of negative 4 is asking you what is the height of this function when the x-coordinate equals negative 4. The x-coordinate equals negative 4 right here. The height right here is positive 1. So that thing equals 1. What about f of 3 halves? Well, same thing. It's asking for the height, except now the height at 3 halves. 3 halves is 1 1/2, so it's between 1 and 2 here. The height right here also appears to be 1. So this equals 1. What about f of 3? It's asking you for the height when x equals 3. 1, 2, 3. It's talking about this point right here. The height is again 1. This equals 1. All three of them equal 1. The answer would be D, that both 1, 2, and 3 all equal 1. 27. Man, just reading this is kind of a lot. But if you stare at this graph, it might be worth looking at this graph first. You can save yourself some time kind of skipping through this problem. What's going on here is I have temperature over time, and something is insulated and something is non-insulated. And that kind of makes sense, right? They start out at the same temperature. And if you don't have insulation, it cools down really, really quickly and gets close to this temperature, this room temperature, presumably. So the room temperature must be like, I don't know, 25 or so. It gets close to the room temperature really quick. And then when it's close to the room temperature, the temperature is not changing a whole lot. If you have an insulated cup, the temperature won't change as quickly. So the temperature starts out changing much less quickly, but then when we get down, because the temperature is changing less quickly, the temperature difference between the insulated cup and the room temperature is greater. So this continues to cool. So it actually ends up cooling quicker down here at the end. So, okay, you read through the problem, and it says exactly what I just said. You have two samples that both start at 60 degrees in a room that's 25 degrees. And the graph shows the temperatures of those samples in 10-minute intervals. And what you're asked about is the rate of change. So what this first one says is that in every 10-minute interval, the magnitude of the rate of change of temperature of the insulated sample is greater than that of the non-insulated sample. That's false. This is saying that insulated always changes quicker than non-insulated. It's tempting to think that's true because it starts out changing quicker. There's a lot of change going on here. But look at the end down here. Insulated is hardly changing at all because it got down to room temperature so damn quick. So insulated is still changing. Non-insulated is barely changing at all. So in every 10-minute interval, the magnitude of the rate of change of the insulated sample is greater. So that's not true because of the start here. I actually told you the wrong thing. At the start here, insulated changes very slowly because it's not insulated. If it's insulated, that makes the temperature change less at the start here. So anyway, it's not A. And it's not B either. It's not B for the first reason that I gave you. B says the rate of change of the non-insulated sample is always greater. That's not the case. That's true at the start, but that's not true here at the end. C says at the start, from 0 to 10 and 10 to 20, the rate of change of the insulated is greater than, so let's see if that's true. At the start, the rate of change of the insulated is not greater. Right? At the start, insulated hardly changes at all, whereas non-insulated changes a ton. So that's not the case. What about D? At the start, the rate of change of non-insulated is greater. Yeah, that makes sense because at the start, non-insulated changes really, really fast. At the end, 40 to 50 and 50 to 60, the rate of change of the insulated is greater. Yeah, these boxes are changing by more than these circles here, and that's because non-insulated has already kind of made all of its change. It's already gotten it all done by the time we got down here. So D would be correct. 28. In 28, you're told this is a square, and the point E is the center of the square, and the coordinates of the points C and E are 7, 2, and 1, 0, respectively. So this right here is 7, 2, as it appears to be on this graph, and this is 1, 0. And what you're asked is which of the following is the equation of the line that passes through the points B and D. There's B up there, and there's D down there. So I'm talking about this line roughly there in green. I bet I can rule some of these off right off the bat. This line should have a negative slope, because if I read it from right to left, it goes down. It should have a negative slope that is more negative than -1, because -1 would be this diagonal line, and this is steeper than that. And it looks like it should have a positive y-intercept. So let's see. Here, my slope is negative, but it's not more negative than -1. This is shallower than -1, this -1/3, so it can't be either of these two answers. It has to be one of these two guys right here. This one, it looks like my y-intercept is -1. I do not cross this y-axis at -1. I cross it way up here at what appears to be 3. Here, if you take the -3 and distribute it through, maybe arrow, I get y equals -3x plus 3. Without doing any calculations at all, I can tell you that this answer is B just by kind of looking at the graph. If you didn't see that, you could actually calculate this. So another way you could do this problem is figure out the coordinates of B and D respectively. And you have two ways you could do that. You could kind of just look at the picture. It appears that this point is at 3, -6, whereas it appears that this point is at -1, 6. And if I have 2 points on a line, I have all the information necessary to come up with the equation of that line. I can figure out the slope by doing y2 minus y1 over x2 minus x1. So there's x1, there's y1, there's x2, there's y2. If I do y2 minus y1 divided by x2 minus x1, what I get is -12 over 4, which is -3. So I know my slope is -3, unlike these two right here. And then if I want to figure out the y-intercept, I could use point-slope formula line, which is y minus y1 equals m times x minus x1. I already solved that m was equal to -3. So y1, I guess to be consistent, maybe I'll let this guy be y1, plug it in there. x1 is -1, so I got x minus -1. I get here. So I got, wait a minute, that doesn't look right. Never mind. So I got y minus 6 equals -3 times x plus 1. If I take that -3 and distribute it, I get -3x minus 3, which is what threw me off at first, but then I was like, oh, right, I still have to add that 6 to both sides. I get y equals -3x plus 3, which was exactly what I was trying to get here for answer B. All right, 29. In the system of equations above, a and b are constants. Which of the following values of a and b does the system of equations have exactly 2 real solutions? You could do y equals 3, so change this into a 3 and plug in these numbers and figure out how many solutions you have in each case. But there's a better way. If you think about what the a and the b represent here, it's function transformations. The b tells you, you start out with your standard parabola, y equals x squared. It looks something like this U-shaped graph. This is y equals x squared. And then y equals 3 is a horizontal line with a height of 3. So maybe I'll make that y equals 3. And so that's what you kind of start out as. And then what b does to this graph in red is it shifts it up by that amount. And what a does is it stretches it vertically by that factor. And if a is positive, this graph opens upward. If a is negative, this graph opens downward. And what's important with these problems is that when you're applying function transformations, you have to apply the a before the b. But I guess that won't be too important with this specific problem. So if we go through and look at these, if b equals 2, that means this graph is shifted up 2. So its new vertex is right here. And if a equals -2, that means it opens downward. This would not intersect this green line in 2 different places. This is not my answer. What about b? Well, in b, my value of little b is equal to 4. So now my vertex is up here above 3. And since a is negative, this thing opens downward. Looks something like this. Hey, look, that looks like it intersects exactly twice. So B would be my answer. To show you that C and D don't work, if B equals 4, here's my vertex again, but when A is positive, this thing opens upward. So I get this looking graph that doesn't intersect the green in two places. That ain't the answer. And for D, B equals 3, so my vertex is right here on the line. A is positive, so it still opens upwards, so I look like this. It intersects, but only at exactly one spot, not two, so that can't be the answer either. My answer would be B. 30. You got this hexagon here. It's a regular hexagon, so all of its side lengths are the same. And then you got this square here. And what you are told is the area of the hexagon is 384 root 3 square inches. And you're asked, what is the area in square inches of the square? Or sorry, in square inches of the square. To figure out the area of the square, you need to know the side length of the square. To figure out the side length of the square, well, note that the side length of a square is the same as the side length of our hexagon. So if I could figure out the side length of a hexagon, I'd be good. There's probably a formula relating together the area of a hexagon and the side length of a hexagon, but I don't know it, so you probably don't know it either. So what I'm going to do instead is figure that out. And the way I'll figure it out is, since this is a hexagon, I can kind of divide it into 6 different triangles here. And since it's 360 degrees all around, that tells me that this right here is 1/6 of 360 degrees, aka 60 degrees. And I got this triangle right here, and in any triangle, the sum of the interior angles is 180 degrees. So if I used up 60 here, I got 120 left here and here. And since these angles are the exact same, they must both be half of 120, aka 60. What I just figured out is that this is an equilateral triangle. That'll be important because if I have an equilateral triangle, I can figure out its area. The area of an equilateral triangle, well, the area of any triangle is 1/2 the base times the height. I know that the base is equal to S, so I have that the area of these triangles are equal to 1/2 times S times whatever H is. I could figure out what H is equal to, figuring out this height. I'd have to use Pythagorean theorem to do it. So this is half of S, and this is S, and I want to know what this is. Well, A squared plus B squared is equal to C squared. Or maybe you'll have memorized the ratios on a 30, 60, 90 right triangle. But in case you don't have those memorized, I'm going to figure out question mark by saying S over 2 squared plus this unknown thing squared is equal to S squared. So this is 1/4 of S squared here. Maybe instead of question marks, I'll call that X squared, and this is a plus, is equal to S squared. So I subtract 1/4 of S squared from both sides, and I get that X squared, which is the height, maybe I should have called this H from the get-go, is equal to 3/4 of S squared. So my height, which I used S for some strange reason to denote, is root 3 over 2 times S. You might have had that part memorized, but for those that didn't, I went and showed you. So what have I figured out? The area of one of these triangles is 1/2 the base times the height. But I don't have just one of these triangles, I have 6 of them. So this is the area of a triangle. The area of the hexagon would be 6 of these 1/2 times S times root 3 over 2S things. I can clean this up a little bit. I can say this is 3. So really what I have is 3 root 3 over 2 S squared. That's the area of my hexagon. 3 root 3 over 2 S squared. But it tells me in the problem that that's equal to 384 square root of 3. I want to solve for S. Let's divide both sides by root 3. That goes away. Let's multiply the 2 up here and divide the 3 down here to figure out that S squared is equal to 384 times 2 divided by 3. You get 256. That's a nice perfect square. You can take the square root of both sides to get that S is equal to 16. If you know that S is equal to 16 here, S is equal to 16 here. If you know that S equals 16 here, you can figure out the area of the square by squaring 16 and getting 256. Wow, that's a lot of work. Is there a quicker way to do it? Oh, maybe. Let's take a look at some of these answers. The square root of 3 is like 1.4 or so. Nope, that's the square root of 2, sorry. Square root of 3 is 1.7 or so. 1.7 times 16 is equal to 27. This answer right here, D, is about 27. If you do that same thing with 64, what you'll end up getting is 110-ish. So I have these four answers, 256, 192, 110, and 27. I'm told the area of the hexagon is 384. This entire thing is 384. Yeah, this is less than 384, but it's not 27, right? There's no way it's that small. There's no way this is the right answer. Are you telling me this is a third of this thing? I don't think so. Could you get 3 of these things and get them inside here? 110 is less than a third of 384, and there's no way you could squeeze 3 of these in here. That can't be the answer either. 192 is half of 384. This isn't even 384. This is 384 root 3. Sorry. So 384 times the square root of 3 is equal to 665. There we go. So it's even worse. Are you trying to say that this thing is 1/6 of this thing? No chance. There's no way this can be the right answer. What about 192? 192 is less than 200. This is more than 600. That's saying this is less than a third of this. There's no way that the area of this is less than a third of this looking at the picture. There's no way that's the answer. If you didn't want to go through all these calculations, you could rule out all these guys just by kind of looking at the picture and reasoning your way through it. That this area takes up most of this area. How much? I don't know, a little bit less than half. This has to be the right answer, and sure enough, algebra verified that it was.